Hello and welcome to another episode of Simply Electronics Basics. Today we're going to have a look into capacitors, what they are, and I'm going to do a little demonstration with a simple circuit to demonstrate what they do. Capacitors are one of the common components that you will find in most circuits, and you will usually find them in quite a high quantity depending on the circuit you are looking at. There are many different types of capacitors for many different uses. Now, unfortunately, every circuit doesn't actually state what type of capacitor I'm using, so this would actually be a polarized electrolytic capacitor. So to get straight down to it, capacitors are a component that will store electric charge. And you may think, well, what's the difference between a capacitor and a battery then? Now, capacitors have one big advantage over batteries. Capacitors can charge and discharge really fast. You can charge a capacitor very quickly, and they can also discharge very quickly as well. And we will get into why that is so useful. Now, capacitors do have a disadvantage over batteries, and that is energy density. A battery can store much more energy in the same space than a capacitor. For a battery and a capacitor with the same physical dimensions, a capacitor would only be able to store a fraction of the energy that a battery could. So capacitors and batteries have their uses in different places. But in front of me we have a simple LED circuit with a capacitor in parallel across the LED. So at first I'm going to demonstrate what happens in this circuit without the capacitor connected. If I open the switch, the LED instantly turns off. All of the current stops flowing through that LED. If I close the circuit, the LED turns on. If I open the circuit, the LED instantly switches off. Now, if I connect the capacitor in parallel across the LED and I switch on the circuit, the LED lights as usual, but watch what happens when I open the switch. Do you see that slow fade there? You see how the LED it's sort of faded out. I'll do that once more. So I've closed the circuit and there is current flowing through the LED, and I open the switch and the LED slowly fades out. Well, why is that happening? So what I've done here is I have connected a voltmeter across the capacitor so we can see what is going on with this capacitor. When I close the switch to this circuit, watch what happens. You can see up here the capacitor has just charged to 3 volts, which is the power that I am supplying the circuit with. So the power supply is lighting the LED, but it has also charged this capacitor up to 3 volts. When I now flip this switch, what will happen is the capacitor will then start feeding this LED, as the capacitor is acting as a power supply for this LED until the voltage of the capacitor is too low to power the LED. So watch the voltage of the capacitor up here as I open the switch on this circuit. You can see as the LED fades out, the voltage of the capacitor is dropping. So the capacitor is charging up, and when I open the switch, it's discharging through the LED, which is why we see that fade as the voltage in the capacitor drops. So here's an example of a practical use of a capacitor in a circuit. Now, you may have seen this circuit before in the video where I covered rectifiers. And the capacitor in this circuit is the one thing that I didn't mention in that video. In this circuit, I have a rectifier which is turning alternating current into direct current. And you can see in this circuit, there are brief pauses as the AC power source runs through 0 on the waveform here. Every time this passes through 0, there is no current flow. And for those brief pauses in time where there is no current flowing through these LEDs in the circuit, this capacitor is actually providing the current during those brief pauses, which keeps the LEDs lit and reduces any flicker, and this is called smoothing. And I can show you what happens when I disconnect the capacitor. You can see what happens to the LEDs. Because this capacitor is not providing that current in those brief pauses, the LEDs are actually flashing because there is nothing to fill in the gaps. So connecting this capacitor in the circuit across those LEDs helps to smooth that and reduce any flicker or interruptions in the circuit. So that's just one simple use for a capacitor in a circuit, and we will be demonstrating more advanced uses of capacitors such as decoupling, buffering, suppression and boosting, but those will come in later videos. If you enjoyed this video, please give it a thumbs up, comment below and subscribe for more.